Okay, good evening. Good evening. Good evening. Can you hear me? Okay. Okay, today we have very important and little bit advanced calculation. Therefore, don't miss at any point. Try to understand. If any doubt, please ask. Okay, you need to understand everything. Today class, everything you need to understand within the class. After that, you can't do anything. Okay, after that, you can only practice. You can't understand. Okay, try to understand 100% within the class. Okay. Last day, we discussed about what is the topic, the final topic, the heat of chemical reaction. Heat of reaction. The heat of reaction means heat of reaction. Okay, what's the meaning of heat of reaction? What's the definition? What's the heat of chemical reaction of any chemical reaction? What's the definition? The amount of heat exerted. The amount of heat exerted means release or absorb. If we think, I told in this lesson, always we think chemical reactions are take place in a system. Open or closed or isolated or whatever system. System. Okay, that's we call as system. What's the meaning of system? I think you can remember the system is any area selected for study from the universe. Any selected area from the universe for whatever particular study, that we call as a system. Always reactions take place inside the system. Inside system. Okay, then what is the meaning of always then react system? Inside react system, reactant convert into product by chemical conversion, that we call as simple chemical reaction. Okay, that is a chemical reaction. That's a chemical reaction. Why? Okay, then what is the heat of reaction? The definition? Heat of reaction means the given balanced chemical equation. Balanced chemical equation while reacting 1 mole of reactant. 1 mole of reactant. As example, think A plus B. A and B are reactant. It is converted to C. C product. C product. Then reacting 1 mole of A. 1 mole of A reacting 1 mole of A. එක mole එකක් convert into product, how much energy is produced? Or how much energy is absorbed? How much heat energy absorbed? In otherwise, 1 mole of B, 1 mole of B reacted, convert into product, how much heat is generated? If it is exothermic reaction, it is heat generated. I think you can remember. Exothermic reaction, the surface heating. Then heat produced, released to the environment. Heat release if it is exothermic reaction. If it is endothermic reaction, the system cooling. Due to cooling, heat absorbed from the environment. Heat absorbed from the environment. Okay, that's the summary. Then what's the heat of reaction? Then how we can define the heat of reaction? I need your support too. What's the heat of reaction? Now we are delayed. We are late. Okay, let's try to quickly come to the lesson. Okay, what's the meaning of heat of reaction? The heat of reaction. Heat of reaction. Heat of reaction. What's the meaning? The heat of reaction means while reacting 1 mole of reactant, in the balance equation given, 1 mole of reactant convert into product. 1 mole of reactant convert into product. 1 mole. 1 mole of reactant convert into product. The amount of heat absorbed or released, that we called as Q, the quantity of heat. The quantity of heat while reacting 1 mole of reactant, that we called as 1 mole of reactant in the balance equation. I will explain now what's the meaning of balance equation. Okay, in the balance equation, 1 mole of reactant converted to product produce Q, produce heat energy or release heat energy or absorb heat energy, that we called as the heat of reaction. Heat of reaction. Then the heat of reaction equal, what is the equation? The heat of reaction equal the quantity of heat divided by number of reactant mole. Understand? Number of reacted, again already reacted, number of reactant molecule, number of reactant moles, number of reactant moles. The quantity of heat we called as Q. Number of reactant molecules we called as N. Number of N, simple N. Then the heat of reaction, HOR, heat of reaction equal Q over N. Q over N. Then what is the unit of heat of reaction? Rehlan, what's the unit of heat of reaction? Unit of the heat of reaction. What was the unit? The unit of the heat of reaction? Quickly. The standard unit of heat of reaction. Now, I told last day lesson is very important for today. Otherwise, you can't understand this calculation. Kabir, what's the unit of the heat of reaction? Very good. Now, no need to remember, right? The quantity of heat unit joules divided by number of moles, unit MOL, mole. Then JMOL minus 1 joules per mole. Per 1 mole, how many joule is released or absorbed? I think now you have full idea. While reacting 1 mole, per mole, how many heat energy is absorbed or released? If it is exothermic reaction, it is released. Endothermic reaction, absorbed. Any doubt up to now? Please ask. Any doubt up to now? I think you have full theory note. If you don't have, I can give you PDF printed type notes as a PDF. I can give you. I have already tutored because in PDF it is difficult to read and understand. When you have your written note, it is difficult. It is easy, I think. It's easy for these 2 lessons only. After that, for theory notes, I'll give you notes. Theory lessons, full theory lessons, cell structure, environment chemistry. All lessons I can give you tutors. I think these lessons, this one and kinetic chemistry also I can give you note, but you have to note down important things. Kinetic chemistry also I have tutored. But it's also same. Kinetic chemistry also small lesson, same as thermal chemistry. Okay, any doubt up to now? Understood? Pehla? Pehla? Okay, good. Amina? Hudarnya? I think okay. Okay, then after that, I already explained what are the steps of heat of reaction calculation. Okay, steps, very important. What is the first step? What's the first step? Steps. Steps. Steps of heat of reaction calculation. Steps of heat of reaction calculation. Okay, what's the first step? Tihini? Balance the given chemical equation. 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 Okay, what's the second step? Rela. Balance the given chemical equation. What is the second step? What's the second step? Balance the given chemical equation. It's done. After balancing the given chemical equation, then what I need to do? Yes, good. After balancing, calculate the added reactant number of moles. Added reactant number of moles. Add karapu amount එක. Add karapu number of moles. Added number of moles. Yes, separately. Moles separately. Good. Separately. If it is 3 reactants, separately one by one, we need to calculate. Okay, separate. 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 Separately. Third one, calculate the actually reacted number of moles in reactants. Okay, for that we can use stoichiometric ratio. Okay, the stoichiometric ratio very important for this. Stoichiometric ratio. Stoichiometric ratio. Stoichiometric ratio. Stoichiometric ratio. Stoichiometric ratio. Okay, fourth one. What's the first one? Calculate the quantity of heat. Calculate the quantity of heat. Calculate the quantity of heat. Absorb or release heat amount. That's the meaning of quantity of heat. Calculate the quantity of heat of above reaction. Calculate the quantity of heat. What's the final one? The final one, calculate the heat of chemical reaction. Heat of reaction. Calculate the heat of chemical reaction. What is the heat of chemical reaction equation? Heat of reaction. Heat of reaction equal Q over N. Q over N. we can find the heat of reaction for each reactant. I will explain today. Last week I not explained the full story. Today I am going to explain the full story behind the last week. Actually, for understand, I will give you brief introduction. Okay, today I am going to explain the full heat of reaction, more advanced calculation doing normal A-level chemistry student doing full calculation I will give you. Okay, heat of reaction equal quantity of heat divided by number of reacted number of moles. Actually, if you got fourth part answer, okay, fourth steps answer, you need to divide by separately in third step answer. Okay, that's a final step. I think you can understand. Fourth step answer, that's a quantity of heat, divide by separately third step answers. Okay, I will explain in the calculation. Okay, any doubt up to now? Clear? Dihini? Are you clear? Okay, come to listen. Come to calculations. Okay, question number. Okay, I'm going to starting from question number 4. No, not 4. Question number 3. Okay, question number 3. A 0.3 mol dm minus 3. Okay, I'm going to start with question number 3. After that, I will explain other question. Okay, it is very simple. That's why I selected. 0.3 mol dm minus 3 sodium hydroxide solution of 400 cubic centimeter is mixed with an equal volume mean what is the volume? 400 cubic centimeter. Equal volume of 0.3 mol dm minus 3 nitric acid solution. The initial temperature of the mixture was 33.5 and the final temperature of the reaction is the final temperature after the reaction, that system temperature 36.5 Celsius. Determine the heat of reaction of this neutralization reaction. Okay, let's follow one by one. Okay, first step. Read the No, I will explain the second question. In last class, you told. Yeah. Relan. We discussed the second question next question. Are you okay? Yes. Second question we doing. I'm going to start very simple level, and after that, after you revise the steps, we can go for advanced question. Okay. Okay. First, we need to write the reaction, right? Write the reaction HNO3 plus sodium hydroxide. The HNO3 is a acid, nitric acid. HNO3 is a nitric acid. This is acid plus sodium hydroxide. Sodium hydroxide is a base. Then acid base reaction, is it exothermic or endothermic? Exothermic or endothermic? Exothermic or endothermic? Fatima? Exothermic or endothermic? This reaction, Rehlan? Exo endo. Amina, is it exothermic or endothermic? The reaction? Rehlan, how we can decide? Udanya? Quickly, don't take time. Very simple question, Aya. Yes, it is exothermic. Why? I told in the exothermic reactions, all acid-base neutralizing reactions are exothermic reactions. All acid-base reactions. All acid-base reactions. Any acid while reacting with any base, it is exothermic. Acid-base, none exothermic. Not only that, I told list of exothermic reaction types. You have to remember, okay. They are compulsory questions. Thermochemistry, kinetic chemistry, natural products, industrial chemistry, compulsory questions. You can't miss, you can't skip these questions because actually natural products, industrial chemistry, you can skip. You have a chance to skip because they are asking in the essay part. They are asking essay part. But thermochemistry, kinetic chemistry always asking MCQ and structured essay. Then you can't skip. Okay, remember they are important. Okay, now what are the products? Sodium react with nitrate. Sodium nitrate is produced. Sodium nitrate. Both the 1, no problem. Sodium nitrate plus H2O. Plus H2O. Okay, now I'm going to starting with my first step. What is the first step? What's the first step? Balance the given chemical equation. Balance the given chemical equation. Okay. Now, how to balance this? You have to check hydrogen 2. This side hydrogen 2. Nitrogen 1. It is not nitrogen, it is sodium. Nitrogen only 1. Nitrogen 1. Okay. Oxygen 3. Oxygen 3 plus 1, it is 4. Oxygen 3 plus 1, 4. Sodium 1, sodium 1. It is already balanced, right? It is already balanced. If it is balanced, if there are no any values in front of this reactant, as the one value, it is 1. The stoichiometric value here 1. Then what is the ratio? Stoichiometric ratio 1 to 1 is the stoichiometric ratio. The stoichiometric ratio of the reactants with ratio 1 to 1 ratio. Now, what's the second step? Calculate the calculate the added number of reactant moles. Calculate the added number of reactant moles. Okay, how to do this? I'm going to first calculate the HNO3 acid moles, added moles. How to calculate? Okay, you already know concentration equal N over V. Then I want to calculate N. Then it is concentration into V, right? concentration into V. Then I'm going to directly substitute this equation. N equals CV. N equal CV. Number of moles N equals C concentration. Concentration 0.3, sorry, 0.3, right? 0.3. 0.3 into volume 400. Volume 400. Divide by 1000 to convert into cubic decimeter. To convert into cubic decimeter, then 2020 cancel out. It is 0.3 into 4, it is 1.2. 1.2 divided by 10, it is 0.12. 0.12 moles. 0.12 moles. 0.12 moles. 0.12 moles. Okay, next one. I am going to calculate the HCl added moles. HCl moles, added HCl moles. Sorry, not HCl. Sorry, sodium hydroxide. Right? Sodium hydroxide. Sodium hydroxide added. How many moles added for sodium hydroxide? Okay, sodium hydroxide same, right? N equal 0.3 into 400 into 400 over 1000. The value is 0.12 moles. 0.12 moles. Now stoichiometry same. The reacted number of moles, sorry, added number of moles same. Then all reactants are reacted. All reactants are reacted. No any reactants are remain. No any reactants remain here. Therefore, reacted, third step, reacted, this is the first step. I'm going to write in red color. This is the first step. This is my second step. I'm going to third step. Third step, reacted number of moles. Reacted number of moles. It is 0. In HNO3. HNO3, it is 0.12 mole. Sodium hydroxide, it is 0.12 moles. 0.12 moles. Okay. Fourth steps. Calculate the quantity of heat. Calculate the quantity of heat. In this type questions, I told always these producing solutions are very diluted solutions. Diluted solution. Therefore, specific heat capacity, and in our syllabus, in teacher's guide also given, these solutions, specific heat capacity and density, we can take as water density and specific heat capacity. Please understand. Okay. Then the Q equal MC theta we can use to find the quantity of heat, because there is no any physical state changes. It is only mixing. The temperature difference only 3, right? Temperature difference only 3, because 33.5 to increase up to 36.5. It is exothermic. The temperature is increasing. Temperature increasing. Then the mass of, if it is density equal to water density, how many cubic centimeters? 400, 400, 800. Then 800 gram. 800 gram to convert into kilogram, it is divided in 1000. The specific heat capacity 4200. The temperature difference 36.5 minus 33.5. Do you have this paper? All? Do you all have paper? This paper? Last week I sent in the group, as I remember. Okay. What is the temperature difference? 36 minus 33, it is 3, right? Then 30 to 30 cancel out. 30 cancel out. 80 into 42 into 3. Can you send me? 80 into 42 into 3. Quickly. 80 into 42 into 3. Yes. That's the quantity of heat. Okay, now I'm going to move into our final part, fifth steps. What is my fifth step? Fifth step, calculate the heat of reaction. Okay, now I can calculate the heat of reaction separately for nitric acid and sodium hydroxide. Nitric and sodium hydroxide separately I can calculate the heat of reaction. Okay, I'm going to calculate heat of reaction for nitric, for HNO3. For nitric mean while reacting 1 mole of nitric, how much heat is released? It is exothermic reaction. How much heat energy released to the environment while reacting 1 mole of HNO3? That's the meaning. එක mole එකක් product එකට convert වෙද්දී how much of heat energy released to the environment? Okay, that's the meaning. Then the heat of reaction equal heat of reaction Q over N. Q over N. The quantity of heat, what's the quantity of heat? 10,080 divide by how much number of moles reacted in HNO3? It is 0.12. 0.12 mole. Okay, can you send me value quickly? Kabir? $84,000, right? 84,000 JMOL minus 1. Remember, if it is positive value you got. That's the important point. Last week I not explained this. If it is exothermic reaction, always heat of reaction value is minus value, because quantity of heat energy difference, I told in the exothermic reaction, it is a minus value. It is 10,080, it is minus actually. Actually, it is minus. Therefore, this value also minus. What is the reason? This is an exothermic reaction. This is an exothermic reaction. Therefore, the heat of reaction value is minus. Please note down all reasons. Okay, why it is minus coming? Due to the exothermic reaction. Why in exothermic reaction the energy difference, the Q value is a negative value. Negative value. I told in the exothermic reaction delta E, enthalpy always negative. Negative. Okay. Then it is 84,000 JMOL minus 1. Or it is minus 84 kilojoule MOL minus 1. Any doubt? It is for heat of reaction for nitric acid, HNO3. Okay, if you want, I can calculate. I'm going to write in here. Heat of reaction for sodium hydroxide. We can get separately, okay? The same value divide by 0.12. Same value, it is minus. 84,000 kmol minus 1. It is minus 84 kilojoule mol minus 1. Okay, that's all. Are you good? Any doubt? Okay, what's the meaning? The heat of reaction for both reactant, it is same. Then what's the meaning? Then what's the meaning? In one side, the meaning is the ratio is same. The stoichiometric ratio is same. In otherwise, the exact meaning, while reacting both molecule, same amount of heat, while reacting 1 moles of both reactants, same amount of heat released to the environment. That's the meaning. Fatima, Habib, Rehlan, Amina, Udanya. Clear? Okay, now let's move into our second question. Second question is a question actually. It is very simple actually, no any calculation. Okay, let's move into question number 2. Question number 1 already discussed, right? Dihini? Yes, yes. Question number 1 also same type question. Okay. Let's move into question number 2. A solution of 0.4 mol Dm minus 3 hydrochloric acid with a volume of 200 milliliter react completely with 0.3 mol Dm minus 3 magnesium hydroxide with a volume of 150 milliliter. During the reaction, the temperature of the container increased by 5 Celsius. Then temperature difference 5. Calculate the given data. Sorry, using the given data, calculate the heat of reaction of the process. Calculate the heat of reaction of the process. Okay, I'm going to starting with step 1. Step 1. What is step 1? First of all, I have to write down the reaction because the equation is not given. Don't worry. In exams, always in past papers, always they given the reaction. You need to balance. You need to starting from balancing step. Always they given the equation. Don't need to worry. Okay, it is HCl is acid, magnesium hydroxide is a base. Then again exothermic reaction, acid base exothermic reaction. Then HCl plus magnesium hydroxide, it is twice. Not 2, it is twice. We called as twice. HCl plus MgOH twice. That's the meaning. Because that's not a molecule, it is a compound. OH is a compound because compound mean combining 2 molecules, O and H, it is a compound. That's why we call it is twice. I think you already know that in O level chemistry. HCl plus magnesium hydroxide, then it is produced magnesium chloride, MgCl2, MgCl2 and H2O water. Okay, how to balance this equation? How to balance this equation? Okay, I'm going to starting with hydrogen. Hydrogen, this type, this left side, it is 2 and 1, it is 3. This side only 2. Therefore, I'm going to add 2 here. I'm going to add 2 in front of HCl, then hydrogen 4, and this side hydrogen 4. 4 and 4, it is balanced. Chlorine, this side 2, the right side 2. Magnesium 1, 1 balance. Oxygen 2. Oxygen now 2. And they get oxygen 2. Oxygen 2. Hydrogen already balanced, right? Okay, now the equation is balanced. The first step is done. The first step is done. The first step is done. Okay, let's move into second step. Second step, I'm going to calculate HCl number of moles. HCl number of moles. Okay, how to calculate HCl number of moles? Concentration equal number of moles divided by volume. Then the number of moles equal concentration into volume. The concentration into volume mean, please open this question. HCl concentration 0.4 and volume 200. Concentration 0.2. I'm not going to write the equations now. Volume 200. 200 divided by 1000, then it is converted into cubic decimeters. Cubic decimeters. 20 to 20 cancel out. 20 cancel out. 0.2 into 0.2 into 2, it is 0.4. 0.4 divided by 10, it is 0.04 moles. Moles. Then number of magnesium hydroxide moles, MgOH, number of moles added, number of moles added. What is the concentration and volume? The concentration, magnesium hydroxide 0.3 is the concentration. Magnesium hydroxide 150 milliliter. 150 milliliter. Okay, then 0.3 is the 150 divided by 1000. 0 to 0 cancel out. 0 to 0 cancel out. 0.3 into 15, it is 0.45. No, 4.5. 4.5. 4.5 divided by 100. What's the value? 0.045. Am I correct? Am I correct? Habib? Okay, now I have found the HCl number of moles and magnesium hydroxide number of moles. Okay, then what is my, then my first step is done. Second step done. Okay, I'm going to come to third step. What's the third step? Third step is the most important point. Third step is the most important point. Okay, this value correct, right? 0.3 and I think, yeah, correct, right? Correct, correct. Are you clear up to now? I'm not sure. Please send message. Up to now clear? HCl 0.4, 0.4, 0.2 into 2, it is 0.4, divided by 10. In the question, sorry, that's it. Sorry. In the question, right? Yeah. Now, okay. 4 into 2, it is 8. It is 8. Now, okay. Okay. Now, that's the problem. This is the point you need to understand. Okay, now what is the stoichiometric ratio? What is the stoichiometric ratio? The stoichiometric ratio 2 to 1, right? 2 to 1. The stoichiometric ratio 2 to 1. In reactants, product we don't need, only reactant we need to consider. Product any value, only we need to consider reactant. Okay. Then what is my next step? Reacted number of moles. Reacted number of moles. Reacted number of moles, I am going to consider about HCl. Understand? In HCl, added number of moles into the reaction, it is 0.08. 0.08. Added number of moles in magnesium hydroxide, 0.45. 0.045. 0.045. Okay. Now, if we start from this magnesium hydroxide, to complete all magnesium hydroxide, understand? To complete all magnesium hydroxide, how much sodium HCl is required? It is 2 times magnesium hydroxide. That means magnesium hydroxide 0.045. 0.45 multiplied by 2, what is the value? 0.45 into 2, it is 9. 0.09 is required. Is it available? Is it available? Again, I am saying, if we think all magnesium hydroxide is reacted, ඔක්කොම magnesium hydroxide react වෙනවා නම්, if all magnesium hydroxide reacted, 0.45 type, 2 times of 0.45 need to available sodium HCl, hydrochloric. But it is not available, I think. Can you understand? 0.045 into 2, 0.9. It is limited. HCl limited, therefore not available. Therefore, not all magnesium hydroxide is reacted. All magnesium hydroxide react කරන්නේ. Therefore, some amount of magnesium hydroxide is remain. Then if we think this type, this side, to all HCl react, how many magnesium hydroxide is required? How many magnesium hydroxide is required? It is half the from 0.08. It is 0.04. It is available. It is available. 0.04 වලට වඩා තියෙනවා. Then magnesium hydroxide remain. All HCl reacted. Then understand HCl number of moles. Reacted HCl number of moles 0.08 moles. Reacted magnesium hydroxide moles 0.04 moles. Do I need to explain again? Habib? Others, send your feedback about these two values. Fatima? Okay, try to understand. It is a point. If you understood this point, any question you can do. Okay, I am think all magnesium hydroxide is reacted. Mama hitana. Okay, I am thinking. I think all magnesium hydroxide is reacted. To all magnesium hydroxide reacted, according to stoichiometric ratio, 0.045 times 2 magnesium HCl is required. But 0.045 times 2, it is 0.9. It is only available 0.08 HCl moles. Therefore, no, cannot be reacted all magnesium hydroxide. Magnesium hydroxide okkama react karanna bෑ. Understand? Now, I think all HCl reacted. Any direction you can think. I think all HCl reacted. If all HCl reacted, it need only half of HCl moles. HCl wage half tama react වෙන්න magnesium hydroxide. Then 0.08 HCl reacted, only magnesium hydroxide needs 0.045. Sorry, 0.04, making half of HCl moles. 0.04 is required. Okay, then it is 0.04. Okay, in future questions, you can understand. I think you got the basic idea. Rehlan? Rehlan? Amina? Udanya? Please send me. If you not understood, please send me. Then I will explain again. Okay, Rehlan. In future parts, future discussions, you can understand. Yeah, this point is the most difficult, I know. Others, if you not understood, honestly send me, then I can understand your level. Then I can explain according to that. Amina and Udan. Okay, Dihini. Don't take very complex. It is simple thing. Mebala. To react, all think I am explaining into other direction. If I think all HCl moles are reacted, 0.08 full reacting. Okay, I think we don't know. I think if it is reacting all HCl moles 0.08, how much magnesium hydroxide is required? Only half from this, making half tama only. Because according to, see, stoichiometric ratio, make a 2 times the half tama only. 0.08, half, 0.04 is required. It is available. 0.04 to vada thiyena. It is more than 0.04. Then it is possible. This direction possible. But if you think this direction, 0.045, all reacted. All reacted. Is it possible? 0.45 wage dekak pone. 2 times 0.045 required. Then 0.045 you can multiply with 2. Use calculator. 0.045 multiply with 2. It is 0.09, right? But it is available only 0.08. Then it is not possible. Then actual way all HCl moles reacting. ඔක්කොම HCl react කරනවා. Magnesium hydroxide only 0.04 reacting. Only 0.04 reacting. 0.005 magnesium hydroxide moles is remain. Every reactions, not all reactants are reacting. Some reactant particles are remain, not reacted. How about now? In future questions you can understand. Amina. Okay, these questions practice very important. Today itself. Adama, before sleeping, you need to practice at least 2 questions. Same question, okay, no problem. Same question, you need to practice at least 2 questions before sleep today. Or after that, you can again practice after get up in morning. Then again, not forgetting. Okay, you can remember in your long-term memory. Okay. Don't try to remember these things. Try to understand how to get these values. Don't try to remember according to this ratio. It is very mechanical methods. Don't try to remember methods. Try to understand the concept. Okay. Okay, my third step. Okay. Okay, I'm going to fourth step. Fourth steps now very simple. Fourth step, Q equal MC theta. The mass of the solution, the final solution, they are mixing, then finally solution is made. The solution made solution, the volume is 200 plus 150, it is 350. 350, I told if it is density of water equal to this solution, then it is 350 grams. 350 grams divided by 1000. To convert into kilogram, you need to know why it is doing. The specific heat capacity 4200. 4200. How about temperature difference? 5. Then I'm going to remove this 3030. Then there's quantity of heat 35 into 42 into 5. Can you send me it quickly? 35 into 42 into 5. 35 into 42 into 5. $35 into 42 into 5. 7,350. 7,350 joules. Okay, I'm going to calculate heat of reaction on this point. Okay, final step, question, step number 5. Heat of reaction for HCl. Heat of reaction for HCl. The quantity of heat 7,350 joules divided by 0.08. 0.08 is the reacted number of HCl. Then divide by 0.08, then we can get the quantity of heat release, the amount of heat release per 1 HCl mole. That's a quantity of, that's a heat of reaction. Then what's the value? Can you send me quickly? Heat of reaction for HCl. 91,875. 91,875 JMOL minus 1. Remember, that's one also exothermic or endothermic. You can understand by equation, oh, the heat releasing, the question given heat releasing. Then always it is exothermic, right? Then it is minus 91,875 joules per 1 mole of HCl. Okay, then I am going to calculate heat of reaction for magnesium hydroxide. Heat of reaction for magnesium hydroxide, it is 7,350 joules divided by, then it is 0.04 or 0.045. Yellow one or white one. Amina? Yellow value or white value? Here divide. Fatima? Very good. Very good. Well done. It is reacted number of moles we need to divide always, because one magnesium hydroxide mole is reacted. The amount of heat generated, the amount of heat exerted, release, we calculate. Then it is, send me value. Rehlan, what's the value? 183,750. 750 JMOL minus 1. That's one also minus, because exothermic. Okay, why it is minus? Why it is minus? Please note down these important things. Why it is minus? Due to exothermic. Due to exothermic. The heat of reaction minus due to exothermic. Okay, that's all. Very simple. Okay, can I erase? Please note down any important point. Okay, can I erase? Please send me. Okay. Please send me message if you complete. Okay, finish. Rehlan? Others? Send me message or I send. Okay, let's move into our next question, right? Okay, question number 3 done. Come to question number 1. Sorry, 4. Question number 4. A solution of 0.2 mol Dm minus 3 hydrochloric acid 0.2 mol Dm minus 3 hydrochloric 200 milliliter react with 0.3 mol Dm minus 1 aluminium 100 cubic centimeter in an isolated container. Isolated mean, I think you can remember isolated system. Isolated mean no any heat energy exchange. No any heat energy exchange with environment. The temperature of the max mixture rise by 6 Celsius. 6 Celsius rising mean temperature difference 6. Calculate the heat of reaction of this process. Process mean reaction. Okay. Please, let's calculate together. Okay. Calculate with me. Okay. Calculate with me. Okay. Let's write the reaction first. It is reacting HCl HCl plus aluminium hydroxide. Aluminium hydroxide revise. Hydroxide revise. Aluminium chloride. Aluminium Cl3 plus H2 water. Water. Then how to balance this equation? My first step. I'm not going to mention steps. I'm going the process. Okay. How to balance the equation? Hydrogen 1, hydrogen 2. Sorry, hydrogen not 1. Hydrogen 4, only hydrogen 2. Then I'm going to add 2 here. I'm going to add 2. Then hydrogen will be balanced. Before that, we need to balance chlorine because otherwise chlorine 3 It is only 1. Therefore, I need to add 3 here. 3. Now we can balance hydrogen. Hydrogen 3 plus 3, it is 6. Then I have to add 3. Hydrogen balance now. Chlorine balance, hydrogen balance, aluminium 1 1 balance, oxygen 3 3 balance, oxygen 3 balance, hydrogen already balanced. Now the equation is balanced. Then how about the ratio, stoichiometric ratio? 3 to 1 now. Good question. 3 to 1 is the stoichiometric ratio. Okay, let's calculate HCl number of moles. HCl number of moles. HCl number of moles. We have to go for question. 0.2 and 200. 0.2 into 200 over 1000. 2 to 2 cancel. 0.2 into 0 to 0.4. 0.4 divided by 10, it is 0.04 moles. Okay. Calculate with me. Okay, up to now, okay. Any doubt, please ask. Aluminium hydroxide, number of moles. Aluminium hydroxide, number of moles. Go to the question. 0.3, only 100. It is 0.03. 0.03. Then aluminium hydroxide done. Number of moles. Okay, I'm come to third step. HCl. Okay, let's go with the previous method. Actually reacted number of moles. Actually reacted number of moles. How about the I'm going to go with HCl first. Now the ratio is 3 to 1. 3 to 1 is the stoichiometric ratio. Okay, I need your answers now. Okay, the HCl number of moles 0.04. Aluminium hydroxide number of moles, added number of moles 0.03. Okay, I need your help. I need your help. How to think? How to think? Okay, think and can you send me both values? Okay, before that, okay, let's start like this. Tell me which one is limited here? HCl or aluminium hydroxide limited? You have to think stoichiometric ratio. HCl, the aluminium hydroxide, the limited. No, Rehla. Don't think about these two values only. You need to think with the stoichiometric ratio. Very good. HCl is a limited. Hari, Baranda. Try to get that. Okay, with 0.03 aluminium hydroxide, if it is all reacted, aluminium hydroxide all reacted, how much hydrochloric required, HCl required? It is 3 times the endone than aluminium hydroxide. Eto aluminium hydroxide 0.03. Then how many moles required? 0.12. 12. Not 0.12. Yeah, 12, right? 0.3 into, sorry, 0.09 the endone. Because 3 times 0.03 into 3 times required, 0.09 required. Is it available? No, HCl only 0.04. Then what is the limited Rella? HCl is the limited. It is not available, only 0.04. Then I am going to think opposite direction. I think all HCl reacted. All HCl reacted. Then all HCl reacting, how much aluminium hydroxide required moles? Kabir. It is only required 0.04 divide 3. It is available. Then aluminium hydroxide additionally available here. It is excess amount. 0.04 divided by 3. It is very small value. It is available. Now okay? Amina. Dehini. Okay, then I am going to write. Rehilan, send me. Or do I need to explain again? Yes, mean explain or understood? Yes, explain. Okay. Okay, that's the thinking pattern. Please practice this thinking pattern. Okay. I think all aluminium hydroxide is reacted. All aluminium hydroxide react when how much HCl required? HCl 3 times aluminium required, because according to stoichiometric ratio 3 to 1, 3 times required, 0.03 into 3 times required, it is 0.09, right? But HCl available 0.04 only. Then all aluminium hydroxide reacted? No. All aluminium hydroxide cannot be reacted. Now you can decide aluminium hydroxide remain, some amount of aluminium hydroxide remain in this reaction. Okay, now you think it's all HCl reacting. For all HCl react, 0.04 HCl with 0.04 HCl, according to a stoichiometric ratio, it is divide by 3 amount required. It is available. This value is, Kabir, what is this value? 0.04 divided by 3. It is only 0.011033 value. It is available. It's available. Then actually in this reaction, 13 moles. It is more than that. Then all HCl, actually in this reaction, all HCl number of moles reacted and some part of HC aluminium hydroxide reacting. Then other amount of aluminium hydroxide is remain without reacting. Udanya, I got. Rehlan, how about now? Think with stoichiometric ratio. If all aluminum hydroxide required more than aluminum hydroxide, okay, 3 times required HCl, because it is 3 times. See, 1 to 3, then it is 3 times required, but it is not available. That's why we can think aluminum hydroxide not on all reacting, only part of aluminum hydroxide reacting, but HCl all reacting. If HCl all reacting, it is only small amount of aluminum hydroxide required, then that is a reacted number of moles. Rehlan, please send message. Send message. Okay. Then reacted number of moles, HCl all reacting, right? HCl 0.04 moles reacting. Aluminum hydroxide only reacting 0.04 divided by 3 moles only. If you want, you can get the decimal value. I am going to as a fraction. Okay. It is 0.013333. Then I'm going to calculate the quantity of heat Q mc theta. The mass of the (300) divided by 1000. Specific heat capacity 4200. Temperature difference 6. 30 to 30 cancel out. 3 into 420 into 6. Send me Q value first. Yes, 7560, right? Joules. Okay, now I am going to calculate the heat of reaction. Heat of reaction. Heat of reaction for HCl. Heat of reaction for HCl. Okay. Now, okay, right. Heat of reaction for HCl 7560 divided by 0.04. Please send me value. Heat of reaction equal Q over N. Uh, 189,000, right? 189,000. Minus 189,000 JMOL minus 1. JMOL minus 1. If you want, you can get minus 189 kilojoule MOL minus 1. Okay, heat of reaction for aluminium hydroxide. Heat of reaction for aluminium hydroxide. 7560 divide 0.04 divide 3. Then I can say to get exact value 7560 multiply with reciprocation 3 over 0.04. Send me value 7560 multiply with 3 and divide by 0.04. I think it is 3 times this value. Yes, it is 3 times, right? 567. 567 and directly writing kilojoule value. MOL minus 1 minus. Okay. If I give you time, can you calculate? It is printing mistake. It's no problem. If it is mistake only spaces, no problem. Okay, let's move into our fifth question. Okay, it is given a sample of 2.76 gram of potassium carbonate, K2O3, is dissolved in 30 cubic centimeter of 2 mol Dm minus 3 hydrochloric acid. The temperature of the resulting solution increased from 5.2 Celsius. Using the data, C equal 4200 K kg minus 1, K minus 1 it is given, don't think about this. And the density of solution 1000, that means water values, and the atomic masses given, K atomic mass, C atoms, carbon atomic mass, oxygen atomic masses are given. The heat of reaction. Okay, last week, if you don't remember, last week concentration lesson, okay, you can do this question. I can give you 3 minutes, try to get this answer. Okay, I finish. Okay, let's calculate a sample of 2.76 gram of potassium carbonate. Potassium carbonate, that means K2CO3. K2CO3. Okay, let's start in first step. K2CO3. K2CO3, potassium carbonate, plus HCl. Then hydrogen carbonate, it is produced, wait, it is produce potassium chloride, KCl. I forgot to give you equation, right? Plus CO2 plus H2O. It is producing carbon dioxide and water both. It is three products. Three products. Okay, then is it balanced? Is it balanced? K2, but only one. Therefore, we have to multiply with 2. K balance, C carbon, carbon only one, correct. Oxygen 3, okay. Chlorine 2, therefore hydrogen 2, now it is balanced, right? Because hydrogen balance, hydrogen 2, hydrogen 2, chlorine 1, sorry, chlorine 2, chlorine 2. Understood? Rehlan? Correct? Okay, then I'm going to calculate K2CO3. K2CO3 moles. Number of moles. K2CO3. K2CO3. Then K2 means 39 into 2. 39 into atomic mass 39. Then 39 into 2 plus C carbon 12 plus 16 into 3. Okay, I got the molar mass. What's the molar mass? 39 into 2, it is 78. 78 plus 12, it is 90. 90 plus 16 into 3, it is 48. 138, the molar mass. The capital M, I think you can remember last week. The molar mass, capital M equal 138 GMOL minus 1. Correct, Habib? 138, right? Yes, then 138 GMOL minus 1. The meaning, the molar mass mean the full molecule, full compound K2CO3, 138 gram per 1 mole. That's a mass of 1 mole. Okay. In last week class, I told that we have discussed equation N equal mass over molar mass. Mass over molar mass. Okay, the mass of K2CO3, 2.76. 2.76 divided by molar mass 138. GMOL minus 1. It is G. Then G to G cancel out. Okay, what's the number of moles, Abhi? Fatima? Zero 0.02 moles, right? 0.02 moles. Who correct this one? Raise hand. Yeah, this is from last week lesson. We already discussed all mole calculations. Fatima correct? Dihini? Amina? Udanya? Great. Next one. HCl 30 volume 30 cubic centimeter, 2 mol Dm minus 3. 2 mol Dm minus 3 HCl moles, added number of moles. What is the equation? The concentration equation. The concentration equation, N equal Cv. The N equal concentration 2, volume 30. Volume 30. 30 over 1000. 0 to 0 cancel. 0 to 0 cancel. 2 to 3 it is 6. 6 over 100, 0.06 moles. 0.06 moles. 0.06 moles. Okay, now how about the stoichiometric ratio? Again 1 to 2. 1 to 2 is the stoichiometric ratio. How about number of moles? K2CO3. Then I'm going to get the reacted number of moles. K2CO3 first. HCl later. It is K2CO3 0.02. 0.02. It is 0.06. Again same method. Again same method. I think all hydrochloric is reacted. Now I think I starting from here. I think all K2CO3 reacted. Harid, all K2CO3 reacted. Sorry. Oh, any direction you can get. Same as previous, I'm going to starting with HCl. Harid, Rehlan understand. I think all HCl, now from beginning, I think all HCl is reacted. Then how much K2CO3 required? Rehlan. All HCl react when how many K2CO3 required? Answer all. Then you can get the full idea. I told the everything you need to understand within the class. Otherwise you can't understand. After class you can only practice. Okay, to react, Fatima, to react all hydrochloric acid, how much potassium chloride So the potassium carbonate moles required. Dehini, how much? To react all HCl, how much number of moles, how many number of moles potassium CO3 required? Understand? To react no, Rehlan, that's the point, you're doing mistakes. Very good. To react all hydrochloric acid, Rehlan, you need 0.03 because make him half phony. Half phony because it is 2 to 1. 2 to 1 mean taking half phony 0.03 to react all HCl. K2 CO3 required half. That means 0.03 required. 0.03 required. It is half from HCl required. Rehlan, good. To react all HCl, K2CO3, how many moles required? 0.03 moles required. But is it available? Not available. Not available. Then all HCl cannot be reacted. All HCl cannot be reacted. Rehlan, now okay? Amina. Okay, now I'm going to think opposite direction. I think all potassium carbonate K2CO3 reacted. Then how many HCl required? It is only 2 times than K2CO3. It is 2 times. See 0.02 into 2. It is 0.04. It is available. Then what is actually happening? Actually, how it is reacting? All K2CO3 reacting with 0.04 HCl. With 0.04 HCl and 0.02 HCl remain. Understand actual story. Actual story. K2CO3 all reacting. 0.02 moles reacting. K2CO3. HCl 0.04 because it is 2 times 0.04 moles reacting. 0.04 moles reacting. And see, it is contains 0.06, then 0.02 HCl remain. Harnil, that's a full story. Udanya, now okay? Udanya, okay? Little bit understood. If you little bit understood, again and again you have to practice with that. Okay. Again and again practicing is the method, you can get full idea. Okay, these points, they, I think in chemistry, they are the most advanced calculation. Again, in next lessons, you don't have calculations. Only kinetic chemistry, you have a small calculation, the rate of chemical reaction. That's only up. Otherwise, you don't have equation, sorry, calculations in chemistry. But this lesson we have little bit advanced calculation. This is actually A-level chemistry. Okay. Now, what is the number of moles reacted HCl? K2CO3 C 0.02 moles. HCl 0.404 mole react. Then quantity of heat Q mc theta. This is another important point. Okay, how about the mass of the object, mass of the solution? How about the mass of the solution? Dihini, Fatima, how about the mass of the solution? Mass. Fatima, what's the meaning of 0.03? It is number of moles, no? It's okay. Mass of the full solution. It is 30 volume and 2 point. Good. Very good. Yes. No, Kabir. It is not 32.7 gram. It is only 30. Because in these calculations, this type small, if we dissolve 2.7 like small gram amount in a solution, this amount we can neglect. We can neglect this mass. We can neglect this mass. Then it is only 30, remember. Only for this type questions. If two solutions are mixing, it is okay, adding. But if any solid part dissolve in a solution, then we can neglect this mass. Always we neglect it. It's a assuming. Okay, assume it is neglected because the effect doing by this 2.76 is very low. The effect doing by 2.76 is very low. Then it is 30 only, remember. Remember and practice they are very well. Divide by 1000. 4200. How about temperature difference? Temperature difference. 5.1. 1, 2, 3, 1, 2, 3. Okay, send me value. Six 55. Is it joule? Yes, 42 into 3 into 5, right? 655.2 joules. Then the heat of reaction for HCl, sorry, K2CO3 first, then 655.2 joules divided by 0.02. Send me the value quickly. Abir, Fatima, Rehlan, send me the value. Three 32,760. 32,760. JMOL minus 1. It is also minus. Why? The question given, heat release, increase. Therefore, exotherm. Heat of reaction for HCl it is 16,000 value. $16,380 minus 16,380 JMOL minus 1. Okay, final. Okay, let's complete. Okay, I can give you 3 minutes. Please try. A sample of 21.45 gram of potassium nitrate, K03, dissolved in an excess amount of water. It is very good point. Excess amount of water. And the temperature of the solution decrease from, it is decrease, very important, 25 to 14.4 Celsius. Given that the specific heat capacity of the solution, it is 642. Now it is not equal to water, it is given a special value. And atomic masses are K 39, nitrogen 14, oxygen 16. Calculate the heat of reaction is a process. Okay, I will give you equation. Potassium nitrate dissolved in excess amount of water. KNO3 plus water, H2O. Okay, sorry, I couldn't remember this. KNO3 plus H2O, KOH, potassium hydroxide. KOH plus HNO3. HNO3, yes. HNO3 means nitric. Yes, that is the equation. Okay, now you can start. Okay, is it balanced? How many potassium? 1, 1. Nitrogen 1, 1. O3. O3 plus 1, it is 4. 3 plus 1, 4. Hydrogen 2, right? Balance. It is balanced. Then the ratio 1 to 1. Okay. I can give you more 2 minutes. I think enough. Okay. Are you finished? Okay, final question. A sample of 21.45 gram of potassium nitrate. This is exam question. Do you know? Potassium nitrate, KNO3, is dissolved in an excess amount. What's the meaning of excess amount? Excess amount. Excess opposite word එක මොකක්ද? what's the opposite word for excess? Then you can understand. Kabir, what? Excess mean? Yes, limited. Opposite word is limited. I think now you can understand what's the meaning of excess. Excess mean actually unlimited. The actual meaning unlimited amount of water. Unlimited amount of water. Is it exothermic or endothermic? Thermic or endothermic? Is this reaction exothermic or endothermic? Amina? Very good. It is endothermic. Why? The temperature is decreasing. Then it is cooling. Cooled down. Then it is endothermic. That's why this the reaction take place, it is cooled down. That's why heat amount, the heat is energy always transfer from high temperature to low temperature. That's why from high temperature to low temperature, it is transfer outside to inside, from environment to system. Okay, let's start. I'll write down the equation first. K2NO3 plus water HNO3 plus K2H, right? KOH. It's no problem changing. Potassium hydroxide. Then I told it is already balanced. It is already balanced. Then the ratio is 1 to 1. 1 to 1. Actually, no need to think about 1 to 1 ratio. Okay. Water is excess. It is given. Water is unlimited. Therefore, no need to consider number of moles. No need to consider water number of moles. Okay, first of all, I am going to get K2NO3 mole, added number of moles. The value is okay. What's the molar mass of K2NO3? What's the molar mass of K2NO3? K2 means 39 into 7. It is 78 plus, not, yeah, 78 plus not K2, KNO3, potassium nitrate. Then it is 39 plus nitrogen 40, oxygen into 648, 39 plus 14 plus 39 plus 14 plus 48. What's the value? Udanya? 101. 101 GMOL minus 1. then N equal mass over molar mass. Mass 21.45. 21.45 over 101 GMOL minus 1. What is this at? 0. Abhi? 0.21 mole. Then is there any data given about water? No, water we don't need. Number of moles, it is excess amount of moles given. Okay, therefore no need. No need. It is given additional amount given. Then if it is additionally available, excess available, how about potassium nitrate reacted amount? It is exactly reacted amount. Remember, reacted K2NO3. No need to think. It is exactly 0.21 reacted because water excess. Potassium nitrate is a limited. Then all potassium nitrate reacted. All potassium nitrate will be reacted. Then Q equal MC theta. Q equal MC theta. Now you only need to calculate the quantity of heat for potassium nitrate. Water mass not given. No any data given about water. Then 21.5 divided by 1000. 4,000, not 4,200. That's the important one. Okay, if it is potassium nitrate mass you use, you can't use water specific heat capacity. It is already given 682. 682 in standard unit, right? JK minus 1. Okay. Temperature difference. What's the temperature difference? 25 minus 14, 10.6, correct? 10.6. 10.6 plus minus no need 10.6. Okay, what is the value? What's the value? Amina? $7,229.2 joules. Then I am going to calculate the heat of reaction. Heat of reaction equal heat of reaction for. Now we can't calculate the heat of reaction for water. We don't know any data. We can calculate heat of reaction for K2NO3. 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 It is 7,229.2 joules divided by reacted number of moles 0.21 mole. What's the heat of reaction? This is the heat of reaction. 34,424.76 JMOL minus 1. Tell me, is it positive value or negative value? It is positive value or negative value? Kabir, what? I can't understand. It is exactly positive. Why it is endothermic? It is positive. No need to add positive mark. Okay, that's all about heat of reaction. The lesson is completed. Now I will send you here thermochemistry full. I will send it to group thermochemistry full lesson tut. Lesson tut mean PDF and tutorial. You have full tutorial. All are exam questions. Okay, my paper is already completed. Next, your tutorial is full exam question, all type exam question. I have separated and I have included in one paper. Then you can try this paper. Okay, that's all. Any doubt you can ask. Amina, Dihini, everything clear? Okay, then as I told before sleep, please practice this question again one time, and again tomorrow morning practice one time. Then it will again not forget. Okay, this ratio calculation, please try one time again before sleep and after get up morning. Okay, that's all. Goodbye. Good night.